Hey, this is Unit 1, Topic 1, Lesson 2, Day 2, and this is the homework that goes with it, and for some reason the homework wasn't posted on the last video, and I had a lot of people ask about this, and it's understandable because this is one of those pretty confusing ones. It's very hard to figure out what this is standing for, so I want to make sure that you understand where it all comes from, and I totally understand if you looked at this and you were completely clueless as to where this comes from. So this is step 1, step 2, step 3, and we're all talking about perimeter. And this is a hexagon. A hexagon has, in this case, 6 is a perimeter. This one had 10 total if you go all the way across, and this one had 14. And what you should have already noticed in the other homework is that it's add 4, add 4. But now we're talking about writing an expression that represents the amount of the perimeter no matter which step you're talking about. And before we do that, we need to understand what would the zeroth term would be. If I were to work backwards, 14, 10, 6, this in this case over here would be 2. And that's going to come in handy when we work later. Okay, so knowing that, this first equation, it's an equation, P equals. So the 1 in this case stands for this one side. Because the way Marshall was thinking about it is what's really happening here, instead of adding 4, it's really a perimeter that's being added of 5 other sides. She started with this one side, and she's thinking that 1, 2, 3, 4, 5 is being added. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so what's really happening to her is that it's 1 to begin with. 5 is the amount of sides that's being added. 1, 2, 3, 4, 5. So when you add the next one, this 1 was already here, and all you're doing is adding 1, 2, 3, 4, 5 in order to create that next hexagon. So think of this image. This hexagon is the same as this image with the hexagon right here, but the perimeter's been added by 1, 2, 3, 4, 5. So that's where the 5 comes in. So it's being added 5 per step, and that's the reason why it's being multiplied by the steps. Now, what is also happening, though, is you're also deducting the previous term. So you're deducting what would have been in the previous one. In this case, it was 6. So we have 1 plus 5 times n. 5 times 2 is 10, plus 1 that we started off made 11, but you also have to deduct what was one previous from that previous step. So if it's the second step, 2 minus 1 is 1. And what that really means is that there's been 1 taken away from the center. On the third step, there's been 2 sides taken away. So that would be 3 minus 1, which would be 2, that didn't count as part of the perimeter, because now that we've added another hexagon, which means this is no longer a part of the perimeter, so you have to deduct that since it no longer counts. So that's what this comes from. This basically comes from what you've taken away. So if I add another hexagon like such, and I know that's a pretty bad hexagon, now what this used to be a part of the perimeter is no longer a part of the perimeter. That's what I'm deducting. So now I'm deducting 1, 2, 3, because step 3 minus 2 makes 4. Actually, that would have been the step 4. Sorry. That would have been the step 4 that I've drawn, minus the 1, 2, 3. So 4 minus 1 makes 3. So it's always going to be 1 less than the step that you're on. All right, so that's question number 4. So question number 5. All right, where did Tyler come up with all this stuff? 6. So I'm going to erase all of this because that's kind of making it messy. So this had a perimeter of 6. This had a perimeter of 10. This had a perimeter of 14. All right, where did Tyler come up with the 6? Why is that a part of his expression? Well, 6 is the amount of hexagons the perimeter per hexagon. So if there were 2 steps, and there's 2 hexagons, then 6 times step 2, 2 hexagons, would be 12 perimeter altogether. But we know that when you put hexagons together, you're losing some of the sides, because you're losing this side to this hexagon, and you're losing the same point to this hexagon. So 6 times 2 is 12, but this doesn't have a perimeter of 12 because you're losing this side of this hexagon and this side of this hexagon. So what you're doing is deducting 2, because every time you have 2 hexagons meeting, you're losing out on 2. So that 2 represents how many sides you're losing per connection of the two hexagons. So when the hexagons connect, you're losing two sides of your perimeter. And it's always n minus 1, which would be the previous term, because there's always one connection less than the step you're talking about. So if we're talking about step 3, there's going to be 2 places where you're losing 2 sides. If it was step 2, there's 1 place you're losing 2 sides. So the reason why it's minus 2 is because that's how many spots, that's how many perimeters you lose per hexagons connecting. And if we were talking about the 100th step, then we know that there would be 99 places where hexagons are touching. So therefore, you're losing 2 sides of the perimeter 99 times. Okay, I know I didn't write it out down here because of what I don't want is you guys just flipping to the end of the video and copying everything I've written. But if you've watched the video, then you understand what I've said, and you can basically translate into your own words. So you would say just like 1 represents the one side on the left, and then 5 represents the 5 sides that are being added for every hexagon that you add next to it. Okay, hope this helps. Thanks for watching. Bye.